Okay, so now we'll be looking at the natural logarithmic function. This is going to be part 1 of a 2. Okay, most important thing you'll need is that 2 to the x is e to the x times the natural log of 2, and that goes for true for any base. This will help you find the integrals and derivative of a to the x type functions. So that's something we learned from last time. Okay, so the integral, or the derivative of the natural log of x is 1 over x. Pretty simple. The integral of natural log of x dx is going to be x times natural log of x minus x plus c. Okay? And the integral of 1 over x dx, in this case it's going to be the integral from 1 to x of 1 over t dt is going to be the natural log, and it's going to be the absolute value. So when you're going backwards, like from derivative to from the function to the derivative, and then you go from the derivative back to the function, you need to include this absolute value portion right there, okay? And it's going to be plus c. Alright, now how to differentiate with logs. This is really kind of cool. So if we're dealing with logs, okay, so for example, finding the derivative of y equals x to the x. Okay. Let's see. Okay, so if we were going to do this type of derivative stuff, okay, we'll learn about that on the next slide. I think I accidentally put that in there a little bit too early, so let's get rid of that part. But let's find the derivative of x to the x. This is kind of cool. Alright, so x to the x, what we would do is use the natural log of both sides. So we'd raise each side to do the natural log. Then we would do the derivative. Okay, this left side would become 1 over y times dy dx, so that's implicit differentiation. And then this right side would be the product rule. Okay, so it would be 1 times the natural log of x plus x times 1 over x. Alright, and then we times both sides by y. Okay, and we already defined y as x to the x power, so we just replace that with x to the x, and we actually are able to get it really right back. So the derivative of x to the x is going to be like this. And the only way to do this type of problem is to use natural logs. So you want to use natural logs both as a tool for identifying which function to differentiate or which function to integrate, but rather you want to use natural logs to get you out of sticky situations where you have a variable in the exponent and you're like, well, if the variable is out of the exponent, I could do that a lot easier. Okay, now the natural log, or sorry, the derivative of a log base a of x. Okay, so this is log base a. So it's almost rewritten like this. Let's get rid of this part right here. There we go. Let's get rid of that of. You'll see what I'm doing in a sec. This is really kind of nice that we can do the subscripts here. So the subscript is going to look like this. Voila. Okay, so the derivative of log base a of x is equal to 1 over x times the natural log of a. Okay, and you'll be using that using the chain rule. So simple as that. Just understand not the chain rule, the quotient rule, because this is going to be a change in base formula. Now the integral of log x dx is going to be x times log x minus 1 plus c. You're not going to see that too much this semester. You might see it a little bit later, but it's definitely going to be helpful to at least know these rules right here, okay? So here's your rules for logs and differentiating them and integrating them. Thank you very much and have a great day. Bye.